The position of a moving object, which is assumed to move on a straight line with a constant velocity, has been recorded for 3 different times. The following table gives the data recorded in the lab. Find the equation of the line of best fit which would represent this data. What quantities do the slope and the y-intercept represent in this context? What is the position of the object at 1.2 seconds? The slope of the line of best fit using linear regression is n sum xy minus sum x sum y divided by n sum x squared minus sum x squared. In the problem that we have at hand, we have sum of the x values equal to 4.1, sum of the y values equal to 26, sum of the values xy equal to 37.06, and sum of the x squared values equal to 6.21. If we plug in these values in the equation for m, we get n, which is the number of data points, 3 in this problem, times sum xy, which is 37.06, minus sum x, which is 4.1, times sum y, which is 26, divided by n, 3, times sum x squared, which is 6.21, minus sum of the x values, which is 4.1 squared. Using calculators, we see that this is approximately 2.52. To find the y-intercept of the line of best fit, we use the equation b is equal to y bar minus m x bar, where y bar is the average of the y values, sum of the y values divided by the number of data points, minus m, sum of the x values divided by the number of data points. This is equal to 26 divided by 3 minus the value of m, which we found earlier, 2.52, times sum of the x values, which is 4.1, divided by n, which is 3. This becomes approximately 5.22. Therefore, the equation between y and x is y is equal to 2.52 times x plus 5.22. Let's remember that y in this equation represents position and x represents time. If we show position by, let's say, capital X, we can rewrite this equation as x is equal to 2.52 times small x, which represent time, and I'm going to show it by small t, plus 5.22. In this equation, we see that x and 5.22 are added or subtracted to each other. You can rewrite this equation as x minus 5.22 is equal to 2.52t. Now, because x and 5.22 can be subtracted, we know that their units should be the same. X represents position, which is measured in meters in our problem. Therefore, 5.22 should have the units of meters. On the right hand side of the equation, we should have meters as well, because on the left hand side of the equation we have meters. Therefore, the unit of 2.52t must be meters. That says that the unit of 2.52 must be meters per second. because only then we would have meters per second times t, which is second, equal to meters, because seconds would cancel from the numerator and the denominator. We therefore observe that in the equation we have found 2.52t plus 5.22, 2.52t has the units of meters per second and 5.22 has the units of meter. In fact, if we compare this equation with x is equal to vt plus x naught, we realize that 2.52 is the velocity of the object, and 5.22, let me include the units as well, 5.22 meters is the initial position of the object, which also is the same as the position of the object when time was 0. If you plug in t equal to 0 into the equation, you would get x is equal to 5.22. And the final part of the question, part C, if t is equal to 1.2 seconds, we can use our equation to find the position of the object. Of course, it's an approximation because the line approximates the data point. The position is found by the equation x is equal to 2.52t plus 5.22, which in our case becomes 2.52 times 1.2 plus 5.22, which is approximately equal to 8.24 meters.